This is homework lesson 19. Homework lesson 19. What we're going to do is divide polynomials. We learned how to multiply two binomials and end up with a quadratic. And we've learned how to factor a quadratic. But what we need to do is learn how to take a polynomial divided by a binomial, or a polynomial divided by a monomial. Uh, and the reason we're going to need that is it's going to help us to find the roots to things that are like x to the third power, x to the fourth power, x to the fifth power. We know how to take care of something that just has an x, and we know how to take care of something that has an x squared. But we don't know how to take care of x to the third and x to the fourth and x to the fifth. We played with that a little bit when we talked about crossing and bouncing, but we made up problems that were the x cubed ones, the cubics, where you could factor by grouping. So they were specially made up problems, but we couldn't have solved every problem like that. And then the x to the fourth and x to the fifth, I just gave you a bunch of the roots. So now what we're going to do now is learn how to find all three roots of a cubic, or all four roots of a quartic, or all five roots if it's x to the fifth power, okay? To learn that process, we've got to learn how to divide all over again, and even for some of us, dividing on paper, we may have forgotten how because of the technology. So we need to learn the steps to division again. So on page 239 of my algebra book, it shows you the steps to division, and then it applies it to units of measure, and then it applies it to the algebra so we can get the process down. All right, so what are the four steps to division? Step one, see how many times it'll go. If you're not sure, just look it down at page 239. Step one is see how many times it'll go. Step two, multiply. Step three, and step four. That's what we're going to do no matter what the application, no matter whether it's numbers, variables, or units of measure, okay? All right, here we go. So, number one, step one. How many times will 3 go into 5? So we see how many times it'll go. Then we multiply. 1 times 3 is 3. Now, y'all watch what we're doing. This becomes important. And then and how do you subtract? You change the sign. When we show subtraction, we're changing the sign. That's important to us, okay? And we're going to get a 2. And then you bring down, and then you start over, right? How many times it'll go? How many times will 3 go into 6? Oh, 26. 8, right? And then you multiply, and then you subtract, and then you bring down. So we're getting the process down, okay? And then you start over. You see how many times it'll go. How many times will 3 go into 29? 9. You get 27 with, let me wipe that out, 2 left over, yes. So we get 27, and then you subtract, and then you bring down, and then you start over. See how many times it'll go. How many times will 7 go into 22? How many times will 3 go into 22? 7. And then you multiply 21, and then you subtract and get 1. We subtract and get a 1. I needed to be able to see that better. Then what do? This is what people forget. You put your remainder 1 over your divisor 3. So you get 1,897 and 1/3. You put the remainder 1 over the divisor 3. Now we don't want to put R. We want to put 1/3. Yeah, so the answer is 1,897 and 1/3. Now, this is important. Is that 1,897 plus, minus, times, or divide 1/3? It's included, so it's plus. It's a plus 1/3, right? It's 1,897 plus 1/3. Okay, I understand that. We're establishing thoughts that we're going to need in a minute. Okay? Yes, and the and is like add, yes. Now, so when we said subtract, what did we do? Change the sign. Okay? And then we put our remainder over our divisor. And we know that that means to add right there. There's an understood plus sign. Right? Okay. Let's look at number 2. Number 2 should work exactly like number 1. Okay? So, we're going to say, how many times will 3 go into 5 days? 1 day times. In other words, let me ask you this. How many times will 3 go into 5x? 1x times. You got to put the variable. 3 times 1x is 3x. So you got to put the name, day. Okay? Remember in Algebra 1 we talked about numbers and names all the time. All right. So we see how many times it'll go. It'll go 1 day times. And then you multiply. What's 1 day times 3? 3 days. And then you subtract. And how do we show subtract? Change the sign. That's good brain training. Change the sign. Subtract. Change the sign. And we get 2 days. And then you bring down. Now, we're not in the days part of our quotient, the answer up here. We're now to the hours part. In units of measure, we got to convert it all to hours, okay? So what did we have left? 2 days. But we want that in hours. How many hours in a day? 24, so that would be 48. Added to the 14 would give me 62 hours. See that? So we're going to take that 2 days, 14 hours, and convert it to all hours. And I left my R out. Okay, so we bring down, but we convert and add, okay, in units of measure. They say we got that? So now we start over. How many times will 3 go into 62 hours? It'll go 20 hours times, right? 3 will go into 62 hours, 30 hours times. 20 hours times. That is correct. Wowie bunga. So, now we're going to multiply. 3 times 20 hours is 60 hours. And then you subtract, which means you change the sign, and you're going to get 2 hours. And then you bring down. We're going to bring down 7 minutes. The unit I'm dividing in now is minutes. So I need to convert those hours to minutes. How many minutes are in an hour? 60 times 2 is 120. Added to the 17, 137 minutes. So we change that 2 hours, 17 minutes to 137 minutes. Now we start again. Okay? And so we say, how many times will 3 go into 137 minutes? 45 minutes times. Now, I should have my 45 over my 17 minutes. You understand that? But I just didn't have room to stick it there. So now we're going to multiply 3 times 45 minutes is 135 minutes. With 2 minutes left over. And then we're going to bring down 23 seconds. Now the unit that we would like to be dividing in is the seconds. But we've got minutes and seconds, so we need to convert. How many seconds are in a minute? 60, but we got two of those, so 120 added to the 123 gives me 143 seconds. And then we start over, see how many times it'll go. Any questions on what we're doing? Everybody see the process is exactly the same. That's what we're trying to show you. We've been trying to show you that since the first day you came to my algebra class 4 years ago. Now, 3 will go into 143 seconds how many times? 47 seconds times. And then we multiply 47 seconds times 3 seconds is 141 seconds. So we're going to subtract and get 2 seconds. Now here we're just going to have to say plus, right, 2 seconds. Or with the remainder of 2 seconds. There's just 2 seconds left over, okay? So we've subdivided a set of time into 3 equal parts. That's probably not something you've done a lot, if you think about it, in your math career in high school. But that's something you might need to do. How do I take time and divide it in half? Or take time and divide it into 3 segments? Or even a unit of measure. 1 mile, 468 feet, 9 inches. How do you divide that into 3 sections? Okay, well, now we know how to do that. The process is, see how many times it'll go, multiply, subtract, which means you change the sign, and bring down and start over. And the remainder gets added, correct? Everybody with us? Now we're going to apply that same thing to algebra, okay? Everybody watching this? When we do this, when we think, what's the first step, first of all? See how many times it'll go. All right? When we do that, we look only at the first term with the first term. Okay? That's the first thing you got to realize. You're looking at the x and the x squared. So we're thinking, how many times will x go into x squared? X times what is x squared? Let me listen to right what you said. First thing I heard was 2. That's the answer to that. The second thing I heard was 1. That's that. X times what is x squared? There we go. All right. I didn't do that as much for y'all's benefit because y'all already figured it out. I did it for the benefit of those who might be listening, those who are watching. Yes. Okay, so we got an x, and then we multiply. Now here's the deal. Is everybody listening? Rule 2, page 37 of my Algebra 1 book. If you multiply 2 or something to or divide something by a sum or a difference. See, we're going times here, right? X times that. When you have a higher operation like multiplication that's happening to a lower like addition, we taught you long ago that you have to put that lower in parentheses and distribute. So when you multiply there, you have to distribute. They understand that? So first thing to remember when you say how many times will it go, you only look at the first term with the first term. But when you multiply, you have to remember distributive property. So we're going to have x times x is x squared. X times 3 is 3x. Y'all study that and make sure you have that down before we move on. Understand that? See how many times it'll go. First with first. Multiply. Don't forget to distribute. Okay? And then we subtract. Y'all watch this part, which means we change the sign. We change the sign of both pieces. Okay? Understand that? Now, x squared minus x squared cancels. 10x minus 3x is 7x. What do you do next? Bring down. Now, those are not like terms, so you can't combine them. It's not units of measure where you would change it, so it stays like that, 7x plus 21. Now we start over. When we start over, we're thinking first with first. Understand that? When we're saying how many times will it go? How many times will the first part go into the first part? How many times will x go into 7x? 7. Positive 7. Okay? Let me erase up here so we can remember what that was. That was an x. Okay? So we see how many times it will go. How many times will x go into 7x? 7. And then you multiply, but you got to remember to distribute, right? So 7 times x is 7x, and 7 times 3 is 21. And then you subtract, which means change the sign, and we get a 0 remainder. So x squared plus 10x plus 21 divided by x plus 3 is x plus 7. Now you could take the x plus 3 times the x plus 7, and you could distribute, as I taught you, x plus 3 times the first chunk x, and x plus 3 times the second chunk 7, x squared plus 3x plus 7x plus 21, combine like terms, x squared plus 10x plus 21. And we could verify that this times this is that. Therefore, the x squared plus 10x plus 21 divided by x plus 3 must be the x plus 7. We could verify by multiplying the binomials. Okay? Any questions on number 3? See how many times it'll go? We look at first with first. Multiply, don't forget to distribute. Subtract, meaning change the sign. Bring down. Okay? All right, number 4. Step 1. See how many times it'll go, and we look with first. 2x times what is 6x squared? 3x. And then we multiply, and we remember to distribute. So we're going to get 6x squared plus 9x. Understand that? And then we subtract, which means change the sign, and we're going to get 8x because the 6x squares are gone. Oh, I didn't see it. Thank you. Wow. This was a, let me rewrite that. Wow, that got hard to see. I didn't see it. Okay, so we had 6x squared plus 9x. And then to subtract, we change the sign. Those cancel. That's a negative x and a negative 9x, which is a negative 10x. I didn't see my negative there. There you are. Thanks for helping out. And then we're going to bring down. And then we see how many times it'll go, and when we do, we look at first with first. 2x times what is negative 10x? Negative, and it goes up here, so minus 5, right? And then we're going to distribute that. Negative 5 times 2x is negative 10x, and negative 5 times 3 is negative 15. Then you subtract, which means we change the sign, so they become positives. They're opposites here, they cancel. They're opposites here, they cancel. We get a remainder of 0, so it goes in evenly at 3x minus 5. Any questions on number 3 and 4? Now, if we apply that to an x cube, notice what we did. We went from an x squared to an x to the first. If this had been an x cube, it would have gone down to an x to the second. So we're able to keep dropping one as we do this. Yeah, so we're dropping the power by 1 by dividing by a power of 1. Okay? Any questions so far? Well, I better stop there because we don't have time to go through another one. Well, that got us started. So anyway, hopefully remember the connections between the numbers, the units of measure, and the algebra.